Alright, so today we're going to start with area of circles, and then we're going to be getting into finding areas of parts of circles like sectors and segments and the annulus. Okay, so first things we need to know is what is the area of a circle. Okay, and the area of the circle is given by the formula A equals r squared times pi. Okay, where A is the area and r is the radius of the circle. Now it looks very similar to our circumference formula, okay, which you also need to know. So I would also add in the circumference if you don't remember that from our circle unit. 2 times r times pi. Okay, or remember we had circumference equals diameter times pi. Okay, either one, but see how they look very similar to each other? The area one where the r is squared. Circumference is where we multiply by 2. Okay, so they look very similar, so make sure you can identify the differences between them. All right, we're going to start with a nice easy one here for us. We have a circle with a diameter of 3 yards, and we need to write the area of this circle. So I always start by writing down the formula. You guys need to get into that habit of writing down the formula for every single problem. Okay, so first things, I know the diameter is 3, so that means the radius is going to be 1.5. So make sure you're not putting the diameter in, make sure you're putting the radius in. Okay, so now I have 1.5 for the radius, and when I square 1.5 squared, I end up with 2.25 pi. Now this would be leaving it in terms of pi, yards squared. Okay, or if you are going to put it to like the nearest hundredth, okay, rounding answer would be 7.07 yards squared. Okay, so either way, if you leave it in terms of pi or you round it, make sure you read the directions. All right, next, another one. This time we were given the area or the radius. We weren't given the diameter, so that makes it a little easier for us. One last step we have to do. Okay, I plug in 5 for my radius, end up with 5 squared times pi. So if I'm going to keep it in terms of pi, 5 squared, I get 25 pi inches squared. Okay, and if the directions call for you to round it, okay, an approximate answer would be 78.54 inches squared. Make sure you're always using your pi button. All right, this time they were given the circumference of the circle, and they want us to know, well, what would the area be? Okay, so this is where we're going to use our algebra skills a little bit. So they told us that the circumference was 6 pi, and we need to find what the area is. So we need to figure out what the radius is, right? Okay, because that's the only part of a circle that we need to know. Okay, now we wrote down that the circumference formula was 2 times r times pi. Okay, so if we're looking at this, if I know the circumference is 6 pi, and I know the formula is 2r pi, I can solve algebraically. So I'm going to divide by 2 pi to cancel, divide by 2 pi, and my pi's cancel. So my r ends up being 3 for this one. I know that some of you can just see that by looking at it, but you need to set up this work, the algebra work for it. So now I can plug in my radius into my area formula. So I have A equals 3 squared times pi, which ends up being 9 pi yards squared for my final answer. All right, here's another fun one. This time we were given the area and we needed to find the circumference. Okay, so if we know our area formula is r squared times pi, and I know my area is 16 pi, so I'm going to replace the a with 16 pi, and I'm going to solve for r. When I divide by pi on both sides, my pi's cancel out. So I'm left with 16 equals r squared. Now, how do we get rid of a squared like that? We're going to square root to get rid of it. So r ends up being the square root of 16, which ends up being 4. So 4 is my radius for this problem. Now, they're asking for the circumference, so I need to go to my circumference formula and I need to plug in my radius. So I have circumference equals 2 times 4 times pi. So my circumference ends up being 8 pi inches. Notice that I did not use inches squared. I left it as inches because circumference is the distance around, right? We're not talking squared units, we're just talking about regular units here. All right, 8.6, this is on finding the area of an annulus, sectors, and segments in circles. Okay, so we have 3 big formulas. Make sure you're paying close attention to all 3 of these, okay, because they're very important to this unit. First part is, what is a sector? Okay, and a sector is the region in a circle between 2 radii and an arc of a circle. Okay, I know the picture is kind of hard to see here, okay, but here we have kind of like a piece of pizza, I call it. Okay, it's a piece, it's a portion of the circle. Okay, it's this whole area in here, okay, is a sector. And then what is a segment of a circle? Okay, well, a segment is the region between the chord and the arc of a circle. Okay, so a segment is this portion, this whole piece here. Okay, some people like to just think about a segment being a segment where it's not area, but segment of a circle is a part, it's a whole region of the circle. So we're talking area, that whole blue part here. Okay, make sure you're writing down these, okay? These are going to be important here in just a minute. And then we've talked about an annulus before, okay, where well, maybe not. We've talked about concentric circles before, okay, where we have 2 circles that share the same center, okay? And now the annulus is the region between the 2 circles. So kind of like a donut. No, we're talking pieces of pizza and donuts here. Okay, so an annulus is kind of like that circle piece. Okay, we're going to get into these formulas. They're going to be a little intense, so take your time with understanding them. All right, first I'm going to block a couple out so it doesn't look too confusing. We're first going to talk about the area of a sector. Okay, so an area of a sector is a portion of the circle, the whole circle. So we first need to find the area of the entire circle using our regular area formula. Okay, so we're going to use r squared times pi, and then we need to multiply it by the fraction the circle is to find out what that piece is. Okay, so if we had one, let's say it was 45 degrees in here. Okay, so we'd plug in 45 over 360 and multiply it by the area of the circle to find just that piece or that chunk of the circle. Okay, so make sure you write down this formula here. Area of a sector is going to be the area of a circle and then timesing it by the portion, okay, or the fraction it is of the circle. All right, next we have area of a segment. Okay, I know we kind of have a lot going on here, so just bear with me here for a minute. Okay, area of a segment. Okay, this one's probably the more confusing one of the two. Okay, if you notice here, we created kind of a triangle piece off of it. Okay, where we first are going to find the area of this whole sector. So just like we did in this problem over here. So we're first going to find that entire area of this whole segment. And then we're going to find the area of this triangle we've created with our radii. Okay, so we've created this kind of triangle here, and we're going to find the area using 1/2 base times height. And we're going to subtract it from this entire segment or this sector that we found before. Okay, so we're going to find the area of a whole sector, just what we did over here, and we're going to subtract the triangle to get just this inside segment here piece. Okay, so make sure you're writing these down, taking the time to kind of visualize and understand, okay, how to kind of break them apart. Okay, and last but not least, the area of an annulus. Okay, and the area of an annulus I think might be the easiest one for some of you to understand. Okay, we're first going to find the area of this entire circle, everything, using this big radius. Okay, so notice here we use a capital R to kind of show that the bigger one. So we're going to find the area of the circle of the big one and subtract the inside area of this donut or annulus. Okay, we're going to take the small radius and subtract that area. So kind of big circle minus little circle is going to give us the area of the donut. All right, let's put these to good use here. All right, so for number 1, we're going to find the area of this sector. I'm going to start by writing down the area formula, always, always, always. I know they used an A for angle measure, times r squared times pi. I'm going to plug in what I know. Okay, so I know that the angle measure is 135 degrees, and I know the radius is 14. So when I'm plugging this all into my calculator, please make sure that you're putting parentheses around this whole thing here so that it's not, so your calculator is understanding what's happening. And then I'm going to multiply it by 14 squared, and I end up with 73.5 pi. And this is meters squared. So this is in terms of pi here. And if I wanted it to be rounded, I would get 230.91 meters squared. So this is finding the area of a sector. Okay, and you can just plug in those numbers, just like we have there. Area of a segment, this is kind of the tricky one. Remember, we first have to find the area of this sector first. So we have to do area of the sector, and then we're going to find the area of the triangle. Okay, so we need to first find that sector. Okay, that whole thing, this whole piece here. So just like we did in the last one, okay, 90 over 360 times my radius squared times pi. So then when I plug everything into my calculator, I get 90 over 360, which I know is 1/4, times 6 squared. So I end up with 9 pi here for the area of the sector. And then we have to subtract the area of the triangle. Now they gave us a nice right triangle here, and I know my base and my height are the same. And why do I know that? Think about it. Why do I know this length here is the same as this length here? Because they're both the radii. Okay, so I'm going to take 9 pi and subtract 1/2 times the base times the height. And this should give me my final answer of area of a segment. Okay, so when I multiply 1/2 times 6 times 6, I end up with 18. This is technically in terms of pi because it can't be simplified down. Now, most of the time, they'll have you reduce it. So it'll be 10.27 centimeters squared for your area of a segment. Please write this one down. It's very complicated, I know, so have an example in your notes. Last but not least,